Section 5.6, the hinge theorem. By the end of this lesson, you should be able to use the hinge theorem and its converse to compare side lengths and angle measures. The hinge theorem states if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. Now that's a whole mouthful. So let's take a look at what this might look like in a diagram. So if we have two sides of a triangle that are going to be congruent to two sides of another triangle, that is this first statement. Then the second part of this is saying that if we have the included angle of the first triangle is larger than the included angle of the second triangle, and we can see that 100 is larger than 80, then we can say that the third side of the first triangle is longer than the third side of the second triangle. So since 100 is greater than 80, we can say that RT is going to be greater than VX. So we really have two pieces of information that are required before we can make any statements and conclusions regarding side length. So first you have to notice that two sides are congruent to two sides of another triangle, and you have to be given angle measures for the included angle. Then you can make a statement about the third side of that triangle. The converse of this is also true. So if two sides of a triangle are congruent to two sides of another triangle, and the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second triangle. Once again, it's very wordy, so let's take a look at the picture. So the first part pretty much is the same as the original theorem. And this is stating again that you have two sides of one triangle that are congruent to two sides of another triangle. The second part is what is changing. Here we see that they're saying that the third side of the first triangle is longer than the third side of the second triangle. So we're noticing that 8 is longer than 7. And we're taking a look at the third side. Once we have that information, we can go ahead and conclude information regarding the angles that are included in between the first set of congruent sides. So if you see that you have two sides that are congruent to two sides of another triangle, and the third side is longer than the other third side, then the angle that's included in between those first two congruent sides are going to be bigger than the angle that's included in between the second triangle's included angle. And we can say here that A is going to be bigger than D. All of this is important because it helps us determine and really just compare which segments might be longer or which angles might be larger. So here's a practice problem, and it just simply states which of the following is a possible length for MN. Well, looking at this, we should be able to notice that we have two sides of this triangle that are congruent to two sides of the second triangle. And we also can compare the angle measures of the included angle. And we see that this angle is 50 and this angle is 42. So what I can say is that this needs to be the bigger side in comparison to MN. So looking at these possible lengths, I know that it can't be equal and it shouldn't be larger than it, so it has to be 16 of the different possibilities. Our next practice problem uses the converse. And in this one, once again, we're given some information. We are given that you have two pairs of congruent sides, and we're given some information regarding a third side. And we can see that the third side of DEF is 3.7 and the third side of ABC is 4.3. And we're going to use this information when we answer the question. It says, which of the following is a possible measure for angle C? Well, looking at this, I can see that we have the two congruent sides, two pairs of congruent sides, and since this is the bigger measure and this is the smaller measure, then this needs to be the bigger angle in comparison to this one. So once again, since these segments are not congruent, I can't say that the angle is going to be 20. And I know that it has to be bigger than 20 degrees, so my only option here is 25, and that rules out 15. That is essentially what the hinge theorem is about, comparing different angle measures and side measures. And if you have that, then you're ready for a joke. And our joke is, what does a snowman take when he gets sick? He takes a chill pill.